Ugh, 5 seconds in and this video is already boring. Come on, you gotta let me make that joke once. Hello Internet, my name is Quinn and this is Blondihacks. Today I'm going to make a very often requested project, and that's a tailstock die holder. This is a great beginner lathe project. This can be like the second or third thing that you ever make. These are super useful in the hobby shop, and we're going to make one right now. This is my very well used shop-made tailstock die holder. You've seen this a million times on my channel. Holds 1-inch dies, and it's got a Tommy bar that goes through the middle, and then this shaft on the back is 1/2 inch, and it's designed to slide back and forth on there as you cut your thread. I chose 1/2 inch for that shaft because that's the largest that will go in my tailstock chuck. Now this Tommy bar has a whole bunch of different ways that you can use it for different thread cutting situations, and I'll demonstrate those at the end of this video. Now I'm going to make a new tailstock die holder for these little 13/16 dies. These are popular in model engineering for the really tiny weird threads. And I had initially made this little ring here that sits in there to hold these small dies, and it worked okay, but it's kind of fussy, and these little dies have the dimples 90 degrees apart instead of 180, so my set screws were not really lining up properly. I was just using one, and it worked okay, but I don't know, all of this is a good excuse to make a new tailstock die holder so that I can bring you along. Now there are as many designs for these things as there are home shop machinists. A variation that I like is to make it a solid cylinder and have a recess at one end that takes 1-inch dies and a recess at the other that takes the smaller dies, and then the center is choked down to 1/2 inch for the shaft. Something else you'll often see is knurling around the center to help hold it by hand. These are all great ideas. This is the design that I came up with, and I just like the way it looks and it's worked really well for me, so I'll make another one in the same style. Just for giggles, I went ahead and modeled these in CAD, but you certainly don't need to for such a simple part. But if you want these models and the drawings that I made from it, you can hit up my Patreon. The junk pile was good to me today and supplied this nice chunk of 12L14. It's just barely long enough to do this, but we'll squeeze one tailstock die holder out of this. So I'll chuck it up in the 4 jaw just because it happens to be on the lathe, but you could do this on the 3 jaw, and I'll dial that in. I'll start by facing off the end, as is tradition. And then I will square up the tool post and turn down the OD. I'll see if I can get away with turning this without tail support. And the answer is no, we definitely cannot. That is wanting to chatter. So in with the center drill and then in with the tailstock. And now we can turn to our heart's content, firmly supported. Now this is the kind of part that normally you would make on the lathe, and then there's a couple of cross holes that we need to drill, which you could do on the mill in about 5 minutes, but just for giggles and as an exercise to challenge myself, I'm going to make this project entirely on the lathe with only the drill press to go along with it. I want to do this because I think a tailstock die holder is a really great early lathe project if you're just getting into the hobby, so you may not have a mill yet, and I just want to show you that you can definitely do this sort of thing on a drill press. I would certainly recommend starting with a piece of stock that's closer to the final OD that you want than this piece is. I'm going to be making an awful lot of chips here. You could save yourself a lot of work, but this is what I had, so I want to use it. Now you might be wondering, why is it that model engineers and hobbyists all make tailstock die holders, but you never see real machinists in real machine shops using these things? There's a simple reason for that. First of all, home hobby threads are usually very small, and so a die is a good use case there. And also, hobby lathes tend not to have threading gears in their transmissions, so if you want a single point cut threads, you have to spend 20 minutes swapping and cleaning greasy gears, which is not a lot of fun. So the tailstock die holder makes a ton of sense in the hobby shop, even if you wouldn't bother with it in a real shop. And now our finishing pass. One of the reasons this is a great beginner project is that there are almost no dimensions on this thing that really matter. As long as you get the diameter and the depth where the die sits correct, everything else you can kind of wing it, and if you miss a dimension here or there, it's no big deal. So I am going to now drill through, and this is the hole that's going to contain the shaft that guides the tailstock die holder. So I'll start with a pilot drill all the way through. Then I'll go back in with one size under 1/2 inch, which is what I'm going to ream to. Now in with the largest reamer that I have, the beefy 1/2 inch reamer, which for a hobby shop is pretty darn big. And reaming this is certainly overkill. You definitely don't need to do this. Again, maximum precision, definitely not necessary on this tool because it is just holding a die after all, which is not a high precision cutter in any case. If you're going to set out to make one of these, it's important to understand what kinds of dies you want to use, because these round dies come in a lot of different flavors. First and foremost, they might be split or unsplit. So these are both split. As you can see here, there's a gap in them, but a lot of round dies are not split. The split allows you to close them up tighter as they wear. And then you need to look at the dimples that are there to retain the die in whatever device is supposed to hold them. So as you can see, these little dies have those dimples 90 degrees apart. These larger dies have the dimples 180 degrees apart. So make sure you account for that with the set screws. And on some split dies, you may also want a third set screw that has a point on it that goes into the split here. Because what that does is it holds the split open as you tighten the set screws on the sides. These set screws, as you tighten them in, they're going to retain the die, but they also will eventually collapse this gap right here. So you can put a set screw in the end with a point on it to keep that from happening. And then by extension, that's also your adjustment. You can back that screw out a little bit, tighten these more if you want to close up the die. Alternatively, some split dies like this one have their own little set screw in there, which serves to retain the size of the gap. So you don't have to worry about that with this style. So it is possible to design one super Voltron die stock that holds all of these types in different ways as needed, but that's not what I'm going to do here. I'm just going to make a simple one for this style. And in fact, I'm not even going to bother with the bolt to control the split here, because honestly, just don't tighten them down that hard and it's fine. Now, if you're in the mood to be extra fussy, the set screw theoretically goes on the center line of where the die sits, but if you want to, you can put the set screw just a hair behind center line, because then it's going to encounter the taper in the back of the dimple here, and that's going to tend to push the die back into the die stock and up against the reference surface. And it's going to tend to keep the die nice and square to the work. But before you get too excited about that idea, as you can see, these dies tend to vary quite a bit. The dimple on this one is not even centered. I find them all different depths, and they just really aren't very consistent. You know, maybe if you buy really high quality dies, they are, but these basic hobby grade dies, they are not. So if the set screws aren't perfectly seated in there, maybe your die is going to be a couple thou crooked in there, but honestly, it's really not going to matter. If you need more precision than that in your threads, you're going to be single point cutting them anyway. A die is never going to achieve a very high level of precision in any case. Now in with the boring bar, and I'm going to bore out the recess where the die sits. I'm going to touch off on the end, and then I'm going to set up my indicator here, and that will allow me to measure in precisely the thickness of the die. So these dies that I'm working with are 250 thou, so I'm going to move the carriage in 250 thou using that indicator, and then I reset the indicator with a light preload. The idea here is that I have a preload that's less than a full rotation so that I get some warning when I'm coming up to the zero, but I don't have to remember which lap around the indicator I'm on. And we proceed thusly until we're close to final dimension, and I want you to understand that it's taking all of my willpower not to make 7 or 8 dad jokes about how boring this operation is. We should be close now, so I'm going to deburr this and take a measurement and find out what our final pass needs to be. So for that, I'm going to bust out the telescoping bore gauge, which, you know, if you want to annoy internet commenters, call them a snap gauge, because boy, that drives people crazy. And quick check with the micrometer, and I've got about 10 thou to go on this dimension, so I can go back in. Now, the way that I finish a recess like this is the same way that I do a turning to a shoulder operation. I do a finishing pass all the way into 0 on my indicator, which is setting my depth, and then I lock the carriage and wind the cross slide in instead of out, just like I would with a shoulder. And then back in with a chamfering tool. I'm going to break the inside edge lightly, and on the outside I'm putting a more generous chamfer, both because it looks nice and because it'll make the tool more pleasant to handle. Let's see how we did here. A little test fit with the 13/16 die, and that looks really nice. It's a couple thou larger than the die, so it slips in there nicely, and then the depth looks to be right on the money. We're flush with the outside edge there. Looking good. All right, now we're going to prepare to set up on the drill press now. So I'm going to mark the end of the part here, and then what I'm going to be doing is flipping this guy around and turning a mandrel on the end of it to hold it in the drill press. But to do that, I need to part it off, so here we go. As seems to be the theme here lately, I ran out of room on the parting blade, so manual Yahtzee. Next up is the most difficult decision on any lathe project. Is the leftover stub worth saving? Might be good for something, or is it too small to be useful? Does it go in the drawer, or does it go in the garbage bin? As I said earlier, I flipped it around, dialed it back in, and then turned down a mandrel on the end here, small enough to go in a collet. You'll see how this fits into the plan here in a minute. Because I'm going to do the cross holes on the drill press, it's helpful to do some layout now. So over to the surface plate, get it all nice and clean and free of grit. And I'm going to bust out the height gauge. Not something you see a lot on my channel, but if you're not going to use the mill, then this thing sure is a treat. I'll just do a quick check that it's zeroed properly here. Now all we really need to do is mark the distance of the two cross holes from the end of the part. So the first one is half the thickness of the die. That's going to be the 440 set screws that hold the die in place. So I'll mark that. And then I'm just going to move up to the position where the Tommy bar hole goes, and I will mark that as well. We don't actually need a coaxial line here because the part is still a perfect cylinder. We need the holes to be on the same axis, but it doesn't matter which axis. However, if it does matter, here's how you can do that. So I start by finding the height of the cylinder with the height gauge, and then I move down to half of that distance. And then when I'm getting close here, I'll engage the fine feed there at the top of the height gauge. I'll bring it down to half the diameter of my cylinder, and then I can scribe this line. And this is a really easy way to get a center line on a round part, which can be tricky to do otherwise. This is an area where the height gauge and the surface plate really shine. However, I'm actually not going to use that center line, and I'll show you why here, because we're going to use the collet block to do the 90-degree indexing. So it doesn't matter where the first row of holes lands, as long as the second hole is 90 degrees off. But I wanted to show you that you can do this with layout if you're not going to use a collet block. So over to the drill press table, I'm going to make sure there aren't any burrs on there with my precision ground flat stones, courtesy of Lance Balsey. Thank you, Lance. Next, I'll bring in a recent donation to the channel, a very nice screwless toolmaker's vise. It's got a V-groove in the jaw that's going to hold the cylinder nice and straight, and then I'm going to use an adjustable parallel behind it, and that's just going to serve as the indexing for the 90-degree spacing of the holes. So get that guy seated down on the parallels, and it's seated in the V-groove in the vise, and that's going to also hold it above the vise so we don't drill into it. And now to find the center line, I'm going to use this old school trick. I've got a flat parallel on there. You could use a machinist rule, whatever you have around, and just wiggle it back and forth until it sits horizontal when pinned with the drill. And that'll find the center line at the top to, well, within a couple of thousandths if you're careful. Then I'm going to clamp the vise down, and then I'm going to double check that it didn't move, so we're still on center line. And now what I can do is set up a fence effectively with a parallel clamped to the table. Okay, but that's probably not square to the machine, right? Doesn't matter. Let me explain what I'm doing here. Because the drill press spindle is now centered on the crest of the cylinder there, as long as we move the vise parallel to the axis of the cylinder, it doesn't matter what the orientation of the cylinder is relative to the machine. So we just need the vise to move parallel to its own axis because the vise is holding the cylinder parallel to itself. So I can unclamp the vise and slide it, and the spindle will always stay centered on the same axis that we started on as long as we slide it along our fence there. Now to locate the hole along the axis, I can just line it up on our scribe line and just turn the chuck by hand a couple times, and you can see that the dimple is centered on your line. And if you do this carefully, this will get you within a couple thousandths. And now I can center drill and drill all the way through for the Tommy bar hole. One of the things you really got to watch for in drill press work is that once you're set up, you can't move anything vertically because, of course, it's a round column. So if you have an older round column mill, you may also have this problem. So things like drills can really get you, and that's why something like a set of screw machine length drills is a really good investment if you're going to be doing a lot of drill press work, or if you, once again, have a round column mill. On to the set screw holes now, so I can loosen up the vise, slide it along my fence down to the other layout line, and once again using the little hand spin trick with the center drill to make sure that I'm perfectly centered on my line. Then once again center drill and drill the tapping size for 440, which is what I'm using for my set screws here. I want to take advantage of this setup now for the tapping as well. Now you're not really supposed to put taps directly in Jacob's chucks, but people do it and you can get away with it to a certain extent. Taps are very, very hard, and that's not really what Jacob's chucks are designed to grip. However, it helps to take the belts off of the spindle so that you're not resisting any motor forces there. It gives you a good feel on the tap so you don't break it. And then I'm going to put the tap in here and just tap it by hand using the chuck. Now you can also just start the threads this way and then finish them over on the bench. Once they're started straight with the drill press, then you can finish them. But since I'm here, I might as well do them all the way. For the final trick with this setup, it's time to index 90 degrees for the other set screw. So I'm going to set up an end stop there so I can repeat that position. I'll loosen the vise slightly, rotate it, and then use the adjustable parallel on the collet block to index on the other 90 degrees. And make sure I'm up against my stop, tighten the vise back down, and we are right where we need to be to center a drill, drill, and tap the other hole. Back to the bench now to deburr things. I'm using a combination of Noga tools and needle files. Links to all these tools are in the description below. The final step is to put the decorative taper on the back. So I'm dialing it back into the forge off facing the other way. And I'm setting the compound, which is what I'm going to use to turn this taper. It's a short enough taper that the compound will get it done here. I'm setting it to 17 or 18 degrees. It doesn't really matter a whole lot, just something that's going to look nice. And then I'll tighten that down. And before I do the taper, I'm going to part off the mandrel that we used on the drill press. It's going to be kind of in the way here, so this is a quick way to get rid of it. And now I can start turning that taper. So as I said, I'm using the compound, so I have the carriage locked and I'm using the cross slide to feed in, and then I'm feeding across the work with the compound. You can see that I put a piece of brass tubing on the compound hand wheel there. It makes it much quicker and more pleasant to crank long distances like this. Some people also use a hand drill with a T-shaped bar to power feed the compound, but for this little job, the brass tubing is getting it done. Last step, I'm going to square up the tool post and get my chamfer tool in there and put a nice little chamfer on the inside. The outside is kind of a funky angle, so I'll chamfer that with a file. And that is it for our little tailstock die holder. Now the shaft and the Tommy bar are just simple pieces of round bar, and in fact you don't even have to turn those on the lathe. You can buy stock in those diameters, so I'm not going to show that. I am, however, going to show you the finishing that I'm going to do, which is Brownell's Oxbow Blue. So I cleaned that with acetone, and then this stuff just wipes right on. Now the key to getting good results with this stuff is absolute perfect cleanliness. The part has to be completely and perfectly degreased. If you do that, just wipe the stuff on, wipe off the excess, oil it, and Bob's your uncle. You've got a very nice blackened part. We can test fit with a die here, and that goes in there really nicely. And that is our finished tailstock die holder. Now let's give this thing a test drive. So the shaft goes in the chuck in the tailstock, and we slide that in close to the work. Tommy bar goes in the hole, and I'll show you a couple of different ways to use it. So you can hold the Tommy bar and turn the chuck, or if you need help starting a thread, which often is the case, you can rest the Tommy bar on a block of wood there, and then you can apply pressure with the tailstock on the back of the Tommy bar while you turn the chuck, so you don't need 3 hands for this. And then once you've got it going, you can also just hold the chuck and turn the Tommy bar as such. The Tommy bar can be slid back and forth for more leverage, and you can slide it out of the way once you need to crank that die back off of there. And there is our beautiful, lovely thread. That's a 1/4 thread, which is a very common model engineering thread, so it's very, very fine pitch, perfect for cutting with a die. So that's the final result. I hope you enjoyed watching me make this. I hope you'll make one of these too. Go and check out my Patreon for 3D models and drawings if you'd like to make one of these yourself. Thanks for watching, and I'll see you next time.